So this is the data set. We have the TV, we have the radio, we have the newspaper. So we are looking at the use case of a company, and the company is spending a certain amount of money in TV. This is TV advertising expenses. We're looking at advertising money. How much of money is the company spending on the TV advertising? How much of money is the company spending on the radio advertising? And how much of money is the company spending on the newspaper advertising? So based on the amount of money the company is spending on all these advertising avenues, so based on this amount of money that the company is spending on all these advertising avenues, we are trying to predict, okay, based on this amount of money the company is spending on the advertising avenues, we are trying to predict the sales. It is a sales prediction that we are trying to do. Okay, so purely based on the advertising expenses, we are trying to estimate the sales. We are trying to predict the sales. How much sales are we going to get out of it? So that is effectively what we are trying to do. It's a sales prediction that we are trying to do here, sales forecasting. So it makes it a regression problem because you can see these are the input x's. If you have to frame it in line with what we have discussed. So this is more like the input x's, input x1, input x2, input x3. And based on all these input x's, we are trying to predict the output y. Okay, so this is what makes it a kind of a regression problem. So now let us see the solutioning. Let us see how we can solve it. And this is the first time we are actually seeing something called a Jupyter Notebook. This is the setup we already did. So this is my Jupyter Notebook. I'll double click on it and I'll open it on Colab. So all of you can first follow on what I'm explaining, and then I will give you some time to run the code. Okay, and so first just follow on what I'm explaining. Just another 5 to 10 minutes we will take to explain some parts of the demo, and then we will take some time to give you some time to run the code and do some more case studies on that. Okay, so this is the plan. All right, so now first things first. This is my data. So and whatever you see right now, this is called a Jupyter Notebook. Okay, so you can see the extension of the file is IPYNB. IPYNB stands for Interactive Python Notebook. It's a notebook file. It's not just a Python script. The language that we are using is Python. The inherent language that is used is Python, but it's not just Python. It is Python and something else. So whatever we are seeing on the screen right now is not just Python. It is Python and something else. And what is that something else? What is that something else that we are talking about here? So that something else is relating to. So that something else is relating to the the markdown syntax. It's almost like HTML. Some of you who can relate to front-end development, HTML is a markup language. And if you see a markup language, what we do in a markup language is we decide the structure of the web page. Okay, we decide the contents of the web page. What is the text, what is the body, what is the paragraph. Some of you would have done this long back, like we use HTML tags, paragraph tag, heading tag. We decide the entire structure and layout of the web page. So something very similar here also. So we use not only the Python language. You can see this is a cell. These are called cells in a Jupyter Notebook where the Python code is demonstrated. And obviously, it's an interpreted language. There's no compilation. So every time we have a cell, in a cell we have multiple lines of Python code. And if I hit run, all these code is getting executed, interpreted. So we run the code, we get the answer. We run this cell, we get the answer. So it's an interpreted language. But the best part is it's not just the code. We also have the markdown. Okay, so we can actually create a text cell, a markdown cell, multiple different types. You can actually create a kind of a text cell where you can write markdown syntax. And this you can use for giving headings. You can give titles. You can, all of it you get to see in one interface. And that's why the term Jupyter Notebooks. Okay, you can of course, convert this back to a py file. If that is something you're more familiar with, you can convert it to a Python script. But what we are seeing is notebooks. Now, what is the reason why we don't directly use a Python script? Why do we do development? Like if you look at data scientists and the developers, why we prefer doing development in this kind of an interface? Okay, the reason is simple, because while you're building models, while you're building machine learning models, there is a lot of explorative work that happens. A lot of exploratory work that happens. Okay, so because oftentimes what we will do is we will look at the data. We will spend a lot of time in the initial phase where we look at the data. We try to figure out what are the missing values. We try to figure out what are the outliers. We try to figure out if we need to add some columns, remove some columns, create some calculated columns. So we have to do a lot of that work. And also there are times when we need to plot something. We need to see some patterns. We need to see some correlations. All those things we will have to do. And then we will explore, even during the model building phase. Remember, I told you that we have data and we will use different algorithms and we'll try to build different models. So we'll do that. We'll try to build different models and we'll see the best one. So all this is something that we need to explore. It is not like how we do traditional programming where we have a set of steps and we know the requirements of the system and so we start coding, we write our conditional statements, our loops, declare our variables, and we go on. No. But what we want to do here is this is not like a single set of instructions we are writing. It's a very exploratory way we are doing the entire development. So the process of the initial model building phase, Jupyter notebooks are standard in the industry. So right now we are using Jupyter notebooks that are hosted on Colab. It's free. We are getting a free virtual machine. But you even have Jupyter notebooks on Azure. You have Azure notebooks. We have Google Cloud, Jupyter notebooks on Google Cloud, and we even have Jupyter notebooks on AWS SageMaker. And I just named three of the most popular cloud platforms that we have. So if we have Azure, inside Azure Machine Learning Studio, we have notebooks available there. If you are using AWS, you have something called AWS SageMaker, and there are SageMaker notebooks available there. And similarly, you've got notebooks inside Google Cloud. Okay, so notebooks are absolutely the backbone of data science, machine learning, deep learning development. Once you have built the model, so in other words, once you have learned the rules, once you have the final equation, okay, so once you have designed the model, once you have built the model, now you can go and you can absolutely, kind of, so once the initial model building is done, now you can absolutely go and you can, uh, you can effectively convert it to a script and deploy. So the final deployment part is usually done through a script. After the initial model building has happened, then you can convert it to a script and that can be used for deployment. So that is the next phase that can happen. Okay. Okay. Anyways, now let's quickly take a look at this notebook and understand how uh, what the different parts of this notebook are. Okay. What are the different parts? And as I told you, like we'll try to focus on the practicals. We'll not get too much into the underlying theory of all these things because each of these are extremely deep topics. And even if you look at a typical university program, many of these PG programs that are running, each of these are like 1 year long courses. So even in this simple notebook that you are seeing on the screen, there is a lot going on. So I've shared a lot of code, lot of steps, and it's not possible to go over every single part. Neither is it needed. So if you want some help, if you want some references, do look up. Okay, but all of the steps are not necessary for building a solution. Okay, so what am I trying to say? Okay, let's look at the very first, a very simple machine learning model. And I think what I will also do is, although it's not a planned topic that we have, but I wanted to show you. This is the initial cells, and this is the way you run a cell. Okay, this is the way you can run a cell. I have also done something a little different right now. I'm actually doing something called mount.collab G drive. Now this part is optional. If you want to do it, you can. Otherwise, you can ignore it. Okay, this is basically done to make sure that uh, you are mounting your G drive in this folder space. Now that is completely optional. If you don't want to do it, please leave it. What is the benefit of doing it? What is the benefit of mounting your G drive here? What is the main benefit? The main benefit would be then you can access your G drive files. So remember, my advertising.csv file is present in this advertising case study folder, which is in my Google Drive, right? This is the folder. And if you see the entire path, this is where my folder is present. So the only difference is that, when I mount my G drive on Collab, my G drive will be visible here. But I think if this sounds too complicated for some of you, you can completely ignore the step. You can just download the files as and when I'm sharing. See, I'm downloading the file now. I'm downloading the file now. After a while, it will be downloaded. And once you have downloaded the file, you can simply upload it here. That's it. So you have downloaded it. You can simply upload it here. That's it. Just drag and drop the file. It's a two-part process. Okay, so once you have downloaded the file, you can just go and upload the file. It's just a simple two-part process we can follow. Okay, and what you can do now is uh, you can go and effectively drag and drop the advertising CSV file, and you can just put it here. So now that we have the file, we can easily read the file. You don't need to easily to modify the path right now. So you can see that this is my present working directory. I'll skip the initial part because I told you it's not needed. You can comment out this cell and you can just run the cell. You can click on the play button, or you can just hit Shift Enter as a shortcut. If you want to get some help on the shortcuts, you can find the shortcuts present here, but you can just do hit the play button otherwise. It's an easy way to run the code. And this is the actual Python part where it starts. You can see we are first loading all the Python libraries. In fact, this is what makes Python such a powerful programming language. Not just because the language is easy, not just because it's a high level language, it's easy to work with, but because of its extremely uh, very rich availability of different libraries and frameworks that support the language for different tasks, right? Python is a general purpose language. So, right now we are looking at Python from the perspective of data science and machine learning, but I'm sure a lot of you in the audience, you have used Python for other things like scripting or web development. Okay, so Python has some very good, powerful frameworks, front-end frameworks like Django, which are written in Python. Okay, so you can do a lot of stuff with Python, not just what we are learning. But obviously, the libraries and other things we will be using, the frameworks we'll be using, will be specifically for data science and machine learning. So first, we are using importing something called Pandas. Import Pandas as PD is basically it's a library that is used for data manipulation, and it helps us to work with data frames in Python. Okay, so we will basically be using the Pandas library, and we will use the Pandas library to to go and do uh, to manipulate data frames or tables in Python. Tabular data is what we are working with here. Okay, so if you have a table, if you want to add some columns, delete some columns, you can work with Pandas. Okay. Uh, then we also have something called NumPy. NumPy is basically the base mathematical library, the numerical computing library in Python. So NumPy stands for numerical Python, and we can use it for for performing different numerical operations. So we can use NumPy for that. So NumPy stands for numerical Python. Okay. Seaborn and Matplotlib are typically data visualization libraries. So we can take a data set, we can create a bar chart, pie chart. So we can create different types of visualizations using these libraries, heat maps and all that. And next thing is the warnings library, which we are using to ignore the warnings. So oftentimes these are all open source packages, right? So sometimes some version is, let's say, rendered, like is deprecated, and also some of those error messages might come up, which are pretty annoying. So you can opt to ignore all the warnings in your files. Now the next part is where we are actually loading the data. So as I told you, I'll comment out this piece of code because we'll be taking it locally. I'll just comment out this initial part of the code. And I'll just be saving the work as and when I save anything, you'll see the same file reflected in your Google Drive, but everybody knows what to do. And all that I will do is I will just add another piece of code and say demo equal to pd.read CSV, demo equal to pd.read underscore CSV. Okay. And hey, I mean, look at this. Look at this. Isn't it incredible? What you're seeing on the screen is Gemini. This is Google's Gemini. So even before I type something, Gemini knows what I want to do. Can you see when I start typing pd dot? So it's almost like Gemini understands what I want. Can you see? Can you see the suggestion coming up? This is incredible. So we'll get used to more of this as we go along. But once you see a suggestion, just hit tab, and Gemini will autocomplete for me. There's a lot more we can do, and I'll walk you through some of the other coding features. What are the other really cool things that Gemini brings to the table inside Colab. So there's something called Gemini. Gemini is Google's uh, native large language model that is there in all the different Google products, which is includes including Google Colab. You have it in Google Colab, Google Drive, Google Docs, okay, everything with plans to have it in Google Photos and everywhere, basically. And so what it does is, as you start something in Colab, as you start programming in the collaborative environment, so Gemini will read the entire file. It will read the entire file, and you can basically ask questions about your file. This is not just like a normal chatbot. This is not a normal Gemini chatbot that you open and start chatting. No, this is very context sensitive. You can literally ask it questions from the code that is present in your file, which is what makes it very powerful. You can see it says analyze your files with code written by Gemini. So you can literally upload a file and you can ask Gemini to summarize it. And we'll see this. As we go along, we'll see some more examples of this in action. But for now, let's come back to the basics, because if we straight away start learning Gemini, then you'll probably feel like none of what we are studying is even relevant, because honestly, nothing is relevant. After all these tools and everything that we have today, I mean, they're doing everything for us, right? So, but yeah, the fundamental concepts are still very important, but we'll come to those parts at the end, okay? So pd.read CSV, we load this into a demo data frame. This is the data frame in Python. Uh, and we will see dot head to see the top 5 rows of my data frame. I again did shift enter to run the code, or clicked on the play button, you can see. And whenever you generate code, see, this is the part where I hit tab. You can see that Colab will automatically put it'll put a small gray icon which says that, hey, I think you generated the code. So this is the warning sign. It's nothing wrong in that, but just wanted to let you know that in case you're doing this for some customer or doing this for some client demo, just be very careful that when you generate code with Gemini, you get a small kind of, like, you can remove it also. I mean, but yeah, I mean, you cannot, like, you can see, there's no way you can, like, you cannot delete this thing. So just be careful of that. So maybe you can copy it and paste it somewhere else. Okay, so whenever you generate code, there's a small license thing that will come up, and it'll also basically give you some sources, like from where did Gemini look up the code, because it's a language model. It is also trying to look up the code and give you suggestions from somewhere. Okay, so it's actually going to give you, like, what are the sources that it is pointing to. So when it said read.csv, advertising.csv, it kind of pointed to this particular source. Maybe there was something in this source. Maybe this person who is that finger thief, whatever, Michael something is his name. Maybe this person also did the same advertising.py dataset, linear regression.py, you can see. So maybe the person did something very similar. Okay, so this is the thing. We have loaded our data. We know the X, we know the Y's, all that we can do. So we can see the type, and you see a whole host of options will come up. You can generate plots. You can view recommended plots. There's a whole lot of things you can do with Gemini. You can see type of demo. When we see type of demo, we see a Pandas data frame. This is actually a data frame. A data frame is nothing but a simple table in Python. It's another fancy way of calling it a table. It's nothing but a table in Python. And now we can drop that unnamed column. So remember, there was a first column was actually not useful. So we can drop that column. And this is the structure of my data frame. If you see the structure of my data frame, we can see there are total 4 columns we have. We have TV, we have radio, we have newspaper, we have sales. And these are the 4 columns we have. And the output column is sales. So based on the TV and radio and newspaper, we want to predict the sales. Okay, so based on these 3 columns, we want to predict what the sales will be. So that's the objective that we have right now. Okay, and then we have some other basic, exploration features we can continue doing. These are, again, we can, you can see. And the most important part actually starts from here, where we segregate our data. And this is where we'll start from. We need some X, we need some Y. So all of our discussion in the initial few hours were focused on this. We need some X, we need some Y. And this is the part where we do the segregation. We say X equal to demo TV and Y equal to demo sales. So we are very clearly segregating what is my input X. X is my TV. So TV is my input. The amount of money that you're spending on TV advertising is my input X. And the sales that you're getting as a result is my output Y. So that is the thing that we have done. And now, based on that, we will go and build a machine learning model.